Hi everyone, this is Tianzi Zhang, and welcome to my final project, where my project is about the construction error correction through the language modeling. And first, let me introduce the background of our project. We're in some construction sceneries, there's gonna be some error, like the misaligned, improperly installed, and incorrectly positioned. So how can we fix the error? We're in some traditional ways, we use the manual inspection, but this way is time consuming and also suspectable due to human error. So for this project, we hope to develop a language model for the construction error correction. But at first place, we have to establish the data set, and the total number of the correction sentences in our data set is like the 24,000. And we also have to add some parameters to ensure that the instructions are very clear. So at the first place, there's going to be some components like the doors, the windows, the beams, and also there's going to be the error type like the misaligned, the too high, crack to describe the nature of the error. And also there's a direction like the left, right, above, below, or the west, east to quantify the error, and also specific its direction. And the units is like the meters, centimeters, feet, and the most important things is about the correction actions. So it just provides a specific instruction to correct the describe the error, and it just formulated in the nature language to ensure the clarity and ease of understanding. So I just provide an example there. That's like the door misaligned 2 meters left from intended position and shifted 2 meters to the right to match the plane position. So that's very clear. Then it comes to the model architecture, where the first thing is about to generate the sentences, as I mentioned above, like the components, error type, the direction, unit, and the corrective action. So we train these sentences and examples to make the generation. So we feed it to the GPT-2 model to make the fine-tuning process and computer laws. And whether we terminate this process, it's like to see that whether there are above or more than 2 epochs where the test loss increased in the past 5 epochs. If yes, we terminate it, and if no, we just continue this fine-tuning process. Then I use the radio to build a user interface, so we can just see the code first. So I have already write this code, and there's going to be a local URL, so we just click it, and that was like a radio interface. So at first place, we select an error type like the misaligned, and the error number value is like the 15, and select the components like maybe we use door. Okay, so select a direction, we choose above, and also select a measurement unit, so we choose maybe feet. Yeah, so we submit to see whether the construction instruction is right. So it's like move it 15 feet down, whether it's right, so we check it. So the error type is on this line, so we just move it. Okay, so select the direction, we choose above, so we just move it down. So the sentence is very clear and also very right. So we just carrying out the quantitative result here. We just use some matrix. At the first place, there's the test loss. So our fine-tuned GPT-2 model is 1.21, and the GPT-2 model is above 3. So our model just performs better. And also a criterion is like, is our generated instruction grammatically right and coherent? And we just carried out 100 examples, and 88 out of 100 examples just meet this criterion, while the GPT-2 only 61 out of 100. And then whether the model correctly generated corrective instruction for the construction error, and our fine-tuned model is 93. That's very high also. So the last criterion is whether the generated instruction follows the style of the construction standard, and our is 91, where the GPT-2 model is only 27. So our model is performs better. So for these results, we can infer that our model is very successful, And this successful implementation of this model just represents a significant step forward in integrating advanced technology into the construction sector. So this is all for my project, and thank you for listening.